Hello dear students, today I'm going to talk about new chapter, so chapter 2 is about limit and continuity. So here we are, we are going to talk about new things in mathematics, limit and continuity. First of all, before we are starting, you have a 2.1 in this section, chapter 2. It's just talking about what's the limit. So you can read it. It's not very important really. Just read it because it tells you why we are changing this one to that one. This is the meaning of the limit. So the rate of change means that changing over x-axis, and we have also change over y-axis here. So if you divide change over y to the change over x, you will get the limit. That's the definition of the limit, in case somebody asks you about the limit. Okay dear, so here's about the question. Now I'm going to talk about another thing here in the another section, limit of function and limit laws. In this section our focus will be on the limit laws. How can we deal with the limit? Can you divide or not? That's all about the limit rules. So here's the limit. And what's the meaning of the limit? Limit means that you are approach to something. Now if you have a 1 here, now you know if somebody is here 1.5 and maybe somebody here is 1.5, you know this location. Now if you want to go to 1 from here, but you cannot reach the 1, so it means that you are very close to 1. This means, for example, like 0.999. Can you imagine? Yes, or somebody can imagine more, 9999, and go on. So this means that the limit, you are nearly close to 1, but you are not reached the 1. You didn't touch the 1. In the other side, that's why you say limit from the left side. From the right side, for example, you have 1.001. You are really near to 1, but you didn't in the one location. So if somebody say 1.00001, so in that case he's very close to 1, but he didn't touch the 1 again. So that's why we say limit from the right side and left side. This is the meaning of the limit. In general, here's that talking about the points and the purpose of the limit. Also in the limit we have something else was dealing with the function. Now here you are near to 1, but the function has got how do you say, gap. Also you have this type of function, piecewise function. If you are talking about the limit, usually you are talking about here. Also in here you have again another function. Here's your function h of x. In all of these cases you have a function without touching anything else. So here in the, because we have a gap, we say the limit from the right and left, we are going to get 2. Again here we will get 2. Also you have 2 here. Even 2 limit in the 1, there is no exit. So that's why he's going to tell you something about the graph. Okay, about the graph and the limit. In this graph, if the limit is going to what? Is going to 1. For example, I have limit x going to 1 for this function. So I'm going to get what? A part. I'm going to get 2 in the y-axis. How about here, the second example? Again, if you are going to, if you take the limit to 1, okay, if you get the limit to 1 from right or left side, doesn't matter, you will also get what? Also you are in this function you are closing to get 2 again over y-axis. So that means the input and output, we are removing or playing with the x-axis, and the result will be on the y-axis. How about this function? Even though that's the same, because if you are going to the 1 from right or left, the image of the function is over the y is 2. That's why we say the limit is also depends on the function or the graph. Okay dear. Now here we have two what you can say, we have two discipline, we have a two rule here. Okay, we have what? We have identity function and constant function. What do you mean by identity function and constant function? So in the example 2 in your page 2, okay, example 2, page 2 in the limit, we see that in section 2.2, we see what? If f of x is going to x naught, f of x, you will get f of x naught. How? For example, if x is going to 5 and you have x, you will get what? 5. How about if the limit going to -2 of x, so the result will be identity. It means identity function like x. So the result not change. We just put the value here. We replace it. This is the first. How about the second? Part B, example A. Part B. This is the constant rule. For example, x is going to 5 and now I have 2. You know, this is the constant function, we just put it 2. How about x is going to -2, because you have 2, also you will get 2. This is the constant function, because it's just the number, there is no more things to do with. That's why. Now we have 3 important example here. Example number 4 in page 2, okay? So please try to understand with me, because they are very important. They give you an idea about limit, especially right and left. Now example 4, page 2 in your section 2.2. So example 4a, part A, is say u of x is equal to 0, 1 and x0, x greater than 2. Okay, in that case, the best way to understand the purpose of the limit, it's better to take to sketch the graph, because you know it's a piecewise function and it's easy for you. So y is means that y is equal to 0. So here's the function, the straight line. Okay, y is equal to 0, or y is equal to 1. Where? From here. Okay. So now I'm going to talk about limit about 0. So because we have a number, we separate the limit into the 2 parts, negative part and positive part, okay, left and right of the 0. We are going to talk about the 0. Why? Because this is the critical point here. Now later I will ask you about 1. How about limit of 1 is equal to what? So here, because we have a 0 in the left side, I'm talking about this one for this function u of x, and here's the u of x. So for the left side, here's the 0, here's the left side. When I am going to 0 over x-axis, the result over y is equal to which function? This one or that one? This one or that one? Surely is this one, so it's equal to 0. When I am going to talk about the 0 from positive side, now I am going to the positive. Look at the graph over the y-axis. Where's the graph? Here's the graph. What's equal to what? 1. So here we say is equal to 1. Okay, dear? That's all. How about if I say x approach to 1, to this function u of x? You have the same, so you don't care about anything else. You have 1 here. Okay, here's 1. Okay, right and left. So now for x approach to 0 to 1 from the left side, okay, the graph over y is equal to which? To this one. So I say is equal to 1. How about if I say x approach to 1 from the right side? So from the right side, when the x is approach to 1 from the right side here, the graph over y is equal to what? Again is equal to 1. Okay, dear? That's why we mentioned here 0, because 0 is a critical point, but we didn't mention any other point. Sorry, because there's no change. They are constant function. That's why. So now I'm going to B, part B. G of x is equal to 1 over x 0, x not equal to 0, x is equal to 0. So here's the graph of the first part. Here's the graph of the second part. Just point. You say 0 when x is 0. Now I'm going to talk about 0. I'm going to talk about limit of g of x when x approaches to 0. As you know, we should say limit x to 0 from left side, limit approach to 0 from right side for f of g of x, g of x. So I get what? You tell me, think about it, just look at it. Please, here I need your fully attention. So before you decide, go on, over x. Now this is the part. For example, I'm talking about negative part. I'm going to the x from that part. Show me, here's the blue pen, as x approaches to 0 from left side. Show me about y-axis. Where's the graph? Here? No, here, there. So this graph is going to where? When I'm going to 0, look, it's going to minus infinity. That's why you see it's going to minus infinity. How about here? When I'm approaching to 0 from the positive part, from the right, the graph over y is here, and look at the black one. Here's the black one. Look, when I'm here, he's here. It's here. I'm going to be near over y, 0. I'm going to close to 0, so the graph will increase it, going to up. So that's why I say is equal to infinity or positive infinity, no difference. If you write just infinity, that's enough. Otherwise, you can also write positive infinity. So we got something from the picture, that the picture, they are very important. If you know, if you don't know, maybe I'll give you something like that. You don't know. Now you have a graph also in your exercise. You have a graph and decide the limit. Okay, so you have a graph of y is equal to, for example, the number c, f of x is equal to 0, sine of 1 over x, x greater than 0, x less than or equal to 0. Here's just greater. Okay, that's your function. Okay, now we are going to talk about something very interesting, but really you don't know the graph, so I will give you the graph for this graph, for example, in the exam. So it's oscillating it. Okay, just coming like that and oscillated, and here after the 0 you see what? Less than or equal to 0 is 0. Okay, that's all. So now I'm going to talk about what? Of course, 0 from left or from right. So right, left, sorry, this is the right. So now when I am going to here, this 1 and minus 1, I am going to 0 from what? I'm going to talk about the 0 from right side, positive. So the graph is what? It's not stopping, oscillate. So I will get 1 and minus 1, so there is no limit. And how about this part? If in the exam you have just this question, x approaches to 0 from left side. So when I'm going to the left side of 0, I will get what? Over y. Here's the function. Red one is equal to 0. So you can be careful. And these all basics. Also, you can use it in the what? In the continuity. Maybe I will give you this function and say it's a continuous one. Of course not. Why? Because I'll tell you later. So if you are completely understanding the rules of the limit and the mentality of the limit and the theorem of about the limit, surely you can get the what do you say, the idea about continuity. Now here's the rule. I'm not really mentioning this rule for you, just I am applying it for you. For example, we have a sum rule, means that limit can be distributed over what? Over the addition and subtraction, and also constant multiplication can come to be out. And if you have a multiplication function, we can separate them, then we put the result. And also if you have a product, the same. If you have a question or the division, the same. If you have an n, we can find, then we put the result. If you have a square nth root, also we can put inside and get the result. So instead of just talking about the rules, I'm going to solve these examples for you. Okay, in the example we have what? Example 1, for example, limit of x going to, here write c, I'll write 2, x cubed 4x squared minus 3. So in that case, we mentioned that, we also will recall this as a polynomial. We mentioned that you can directly substitute the number. Why? Because there's no problem in it. So you can directly say 2 to power 3 plus 4 2 to power 2 minus 3, which is equal to some sign. So 8 minus plus 16 minus 3 is equal to something else. So how about another example? Example B. I'm going to example B. We have limit of x, for example, approach to 1, x to power 4 plus x square minus 1, x to plus 5. Because if I put 1 here, the denominator, there is no problem in it. There you didn't get the 0, so you can directly put it down. You can directly substitute this value here. So I get what? Something like that. How about up? Numerator also will get this one. Okay, dear. So do it for yourself. 1 on 1 is equal to 1 over 6. Now I'm going to talk about number C, which is very important. X approach to minus 2. Okay, half of 4x squared minus 3. So try to substitute this example. Observe what would the question. Think about it, then put it in its place. If you get something good, it's okay. Otherwise, you can find another rule. Now, if I put 2, I will see. If I put 2 here, I get what? 2 minus 2 squared plus 3, which is equal to what? 2 multiply 4, right? Minus 3, which is equal to 16 minus 3 is equal to 13. So there is no problem because we didn't give any negative value, so we can directly find the result of the limit. How about another page? We have a page 4. He's going to talk about what do you say? Talk about polynomial. What do you mean by polynomial and what do you mean by fraction or rational? Okay. When we say polynomial, so it means that we have something like that. Polynomial zoradar x square minus 4x to power 4 5x cubed plus 2x minus 2. For example, this is a polynomial. Okay, when we put polynomial, and also we have another polynomial, x to power 3 minus 2 x squared, for example, minus 5. We have also another polynomial. When we put this polynomial over that polynomial, you get what? You get rational function, rational. Okay. Okay, what is now? I have a rational. For example, I would recall as the f of x is equal to x to power 4 plus 5x to power 3 2x squared minus 2, just as an example, over x cubed minus 2x squared minus 10 or 50. So this is the rational. Now how we find the limit of this rational? For the first part, for the polynomial, it's okay, we did it before. However, for rational, we did it also here. So you just substitute the value, and if it's no problem, you will directly you can put it here in its place. Now if you have a problem, for example, we have x squared plus x minus 2x squared minus x. If I put 1 here, I will get what? Look, if I substitute it, I will get 1 minus 1, right? If I put here, I will get 1 minus 1 squared, and 1 squared is equal to 1, and then the denominator will be 0. In that case, if you have a 0 in denominator, if there is a algebraic step, please try to do it. Again, I will repeat it. If you have there's a chance of doing algebraic steps, please try to do it and try to remove 0 in the denominator. 0 ka la balajeri karte. How? Now I will write it down for you. I know this is trinomial, so I can do it by like that. Okay, I get what? X positive negative. So I have a 2 1. So I factored this one. How about this one? There's a chance for getting the taking out one x because there's a common between x squared and x. That's why. So I'll see this. It remains x plus 2 over x. Now if I put limit x to 1 directly, I will see if there's a problem or not. Look, 1 plus 2 over 1 is equal to 2, 3. So there's no problem here. So that's why we changed the undeterminate form, or we changed the undefined form Piranha Nakrao to what? To something else, to getting the result. Why? By what? By doing some algebraic steps. When I say algebraic steps, sometimes means that kawana factor, or sometimes means that conjugate owl, and go on. There's a common another way that you can solve whatever you want. So now I'm going to talk about another example. Example 9 in your page 4, the same section. He's talking about if x is going to 0. Okay, so where's the function? Here's the function: x squared plus 100 minus 10 over x squared. So I cannot directly replace or substitute the value x with a 0 to this function y, to this fractional y, because the rational function, this one over this one, will be what? 0 over 0. How? If I put 0 here, I will get 100, and 10 minus 10, it's okay. About the numerator, it's okay, but about the denominator, it's not okay. It's undefined. So we will try to use the algebraic step, as I told you. Most of them, they are doing a factor, or maybe the conjugate. When you say conjugate, it will be like that. Okay. We will multiply by what? We will multiply by the same thing. That's the conjugate of this one, because you have a negative here, so we change it to the positive. That's all. Okay, dear? Now, how we solve this one? We multiply. The next page, I'm trying to multiply, so x approach to 0. We multiply this one by that one. We multiply it, and I will get what? I'll get what? All this will be changed. Okay. Sorry. Here should be plus. So I'll get what? Look. X squared plus 100, because we will remove this one. Negative this one. Okay, try to do it, because the difference between 2 cube, and also here you have a x squared plus 100, okay, plus 10. Okay, now 100 and 100 will remove each other, and here's x squared also will cancel it, we will eliminate it, so it remains 1 over x squared plus 100 plus 10. Now if I put 0 here, I will see if I have a problem or not again. If we put 0, we get what? 1 over 20, so there is no problem. So we did our algebraic step by what? By multiplying what? Conjugate. Okay, dear? So that's all that we say about the algebraic steps. It depends on some example, by taking what? Common, by factoring, by conjugates. That depends, as I told you. Now here's the rule about what? Here's the rule about sandwich theorem. What's very important, the sandwich theorem. he say that if you have a function and you are sure that this function is between another two function, and you know the limit of this one, if you take a limit of h, for example, limit of here is equal to L, and if you take the limit of g also you will get L, so be sure that the same limit for here will give you the results L. For example, I will leave this one for you. For example, we have sine of x over x, limit x approach to, for example, 0. Okay, so in that case, you know sine of x between 1 and -1, we say do merge, sandwich theorem. It's like a sandwich. Here's the first rule, here's the h, here's g. Okay, here's g. Now your function is f. You can, if you can solve this one, also you can solve that one. So, and you know, if we divide over x, we have a something else. So if x approaches, for example, to some number like infinity, okay, so we take a infinity to here, and we will take a infinity to here, and we will take x to go to infinity here, and in this case you will get 0, so also you will get 0 here. That's why by the result we can say if x approaches to infinity, to sine of x over x will be 0. Why? By sandwich. Theorem. How? Because this part was equal to 0, and also this one is equal to 0 left side, so in the middle we can decide our function is equal to 0. Do not be hurry, we will talk about this one later. Just was an example over the sandwich theorem. We I think we got the, we are in the at the end in the discussion, this section. So I hope you are doing well and preparing this section carefully, because later we will use it a lot, and we will depend on these concepts that I said here today. Thank you for being with me. See you in the next week, in the next lecture.